Hello everyone. Welcome to the Chain Abstraction Hackathon launch powered by Particle Network. Lovely to see everyone here.
Hello. I think I can keep things within our time slot here. I don't think it'll take too long. So
great.
1 second. Let me try to share my screen. Let's see if that works. Okay. Can you guys see that?
Yes.
Perfect. Okay. So basically, I want to kind of kick off the first workshop of this hackathon going through universal accounts and account level chain abstraction specific. As you kind of learned maybe 10, 20 minutes ago, essentially chain abstraction is typically composed of a few different parts, a few different types of infrastructure, and I'll get more into this later. But universal accounts are sort of like the base layer when it comes to user onboarding and basically creating an experience where users can have a single unified balance to access and use your application. So this means they can use assets from anywhere. If they have assets on Base, BNB Chain, Tyco, whatever else it may be, any EVM chain, essentially, they can use your application regardless of where you choose to deploy. And so universal accounts are that basic primitive that essentially allow users to maintain that sort of like universal balance and that unified state across all chains and all applications. And so this means that whenever you're building an application, universal accounts are a very easy, low-hanging fruit to integrate and kind of use as that foundational implementation of chain abstraction, allowing your application to be intrinsically chain agnostic. And so what I'm going to do within this session is kind of go through over the next hour or so. I think we're going to keep it maybe closer to 30, 40 minutes. I'm going to go through what universal accounts really are, how they materialize, and how you can actually start working with these programmatically. But as kind of like some quick context, I went through this briefly earlier, but in case you missed it, my name is Tabasco. My real name is Ethan, and I lead developer relations at Particle Network. We're going to go through this in 3 different parts. We're going to start with understanding what universal accounts are. Sorry, I'm a little bit sick from Token 2049. We're going to start by understanding what universal accounts are and how they materialize, kind of what they actually look like to use and why they're important. That will kind of lead into actually a live demo where I'm going to show you kind of like our very early universal account implementation. So you can actually see balance unification, kind of how that looks like from a demo standpoint in real time. And then we're going to end off with kind of a rough example of what it's going to look like to use universal accounts programmatically. But as a quick warning, this workshop and kind of this session is going to, like I said at the end, kind of go through what it's going to look like to work with universal accounts programmatically and how you can implement this. But our official SDKs for universal accounts are not yet live. We're hoping to have these go live in the next 1 to 2 weeks as the hackathon starts kind of kicking off and as you start building. So these SDKs will be ready for you to start using throughout the hackathon, but they aren't ready just yet. And so later during the session, I'm going to be using our existing Account Abstraction SDK as an example of what the universal SDK will look like once it's live, because it'll function approximately the same way. But you can't start working with the SDKs just yet. We're still a few weeks off. I've been pushing my engineering team to get this as soon as possible, but you know how things go. And so for now, we're just going to start using the Account Abstraction SDK that we have as an example. And then, of course, as soon as we launch the SDKs in 1 to 2 weeks, you guys will be the first to know, and you're going to have access to that documentation as soon as it's ready. But before I kind of get too in the weeds of that side of things, what are universal accounts? And I went through this a little bit earlier and kind of briefly gave a description of universal accounts kind of being this account that allows users to have balances across all chains. But very simply, universal accounts are just smart accounts. They are ERC 457 account abstraction accounts or wallets that automatically bridge funds for end users to pay for transactions on any chain. And so what I mean by this is that as kind of the examples that I gave earlier, as a user, if I have, the easiest way to understand this is, let's say I have an application that's deployed on Base, and that application has me buy an NFT worth $20. That NFT worth $20, let's say on Base, I don't have $20 on Base at the moment. And so, I have $20 that's spread across 4 other chains. Let's say I have, $5 on BNB Chain, $5 on Ethereum, $5 on Tyco, and $5 on Polygon, right? So usually that would require me to go and manually bridge all those funds over to Base and then pay for that transaction. It takes a long time. It's very expensive. So rather, what universal accounts will do is that they'll actually automatically do all these actions. So whenever I want to buy the NFT or pay for this transaction on Base, it'll just, with a single signature, automatically bridge these funds from those 4 different chains and pay for the transaction. And so as a user, I can have funds that are spread across as many different chains as possible. And then the account will just automatically consolidate these and use these funds to pay for transactions anywhere. And so this means that users no longer have to manually bridge or really even worry about where their assets are. They just simply have funds anywhere and they use them to pay for transactions anywhere. This is kind of the essence of universal accounts. Simply, this can be categorized by the line that we use a lot, which is that universal accounts give you one account with one balance usable on any chain. And so right now, while you might have a certain balance for Arbitrum and a certain balance for Polygon and a certain balance for Base, universal accounts have the same balance everywhere. And so this means that I create a universal account using my MetaMask or using my Coinbase wallet or OKX wallet or social logins or whatever else it may be. And then I use applications on different chains, and all of these chains maintain the same balance. If I have USDC on Arbitrum, I have the same amount of USDC on Base. If I have ETH on Ethereum, then I have the same amount of ETH on Arbitrum, and vice versa. It's the same everywhere. And so this is really the easiest way to understand universal accounts. It is just very simply a single source for all of your assets that can be used across any chain without needing to bridge or really even understand the fact that they're spread across different chains in the first place. So this removes the entire notion of really needing to pay mind to the distinct chains that you're interacting with from the user experience. You just use apps, and this is the idea of universal accounts. So also, we kind of briefly showcased this slide earlier when we were introducing the hackathon, but specifically universal accounts basically apply a user-centric abstraction. It's this balance unification. When you look at a truly chain abstraction application, you kind of have two components of it. You have balance abstraction and you have kind of the orchestration part. All right, so a completely chain abstract application allows users to access the application and pay for transactions from any chain. And so this is what universal accounts do. Universal accounts, all it does is give users access to paying for transactions from any chain. This is all they do. It's very simple and it's not any more complicated than that. Additionally, a kind of chain abstracted application can also allow you to execute transaction on any chain with a single signature. This is essentially what the orchestration solutions that we talked about earlier can do, like Cluster, Agoric, and Octo. So I go to an application. In this case, this is kind of like a mock transaction. This is not actually what these transactions look like. But for example, if I wanted to do a transaction with some contract that's deployed on Base, Polygon, and BNB Chain from my universal account, then what you can do is that transaction is paid for using balances, let's say, spread across Base, Arbitrum, and Ethereum. And then that transaction with one signature is actually executed on these three different chains. And so as a user, all I know is that I just clicked execute or I clicked sign or whatever, the transaction confirmed. And then all of this complexity is handled by these infrastructure providers, it's handled by these SDKs. So the universal account automatically consolidates these balances across the different chains, and these orchestration providers automatically execute these transactions on multiple chains with that single signature and essentially orchestrate this transaction workflow. And so this is kind of the core of what we imagine and kind of what we're trying to push here for, which is that chain agnostic, chain abstracted application, universal accounts for balance unification, for giving users access to the application from anywhere, and these orchestration providers to essentially execute multiple transactions on multiple different chains, kind of these chain agnostic workflows. All right, so universal accounts, the only role they play here is you're giving a user a single balance they can use anywhere and consolidating assets from other chains. So if the idea wasn't simple enough, it is explained here. One account aggregating balances from any chain without any bridging required. So let's go ahead and actually go through a live example of what this looks like to use. And so I'm going to open up, I didn't have this open before and I probably should have, but this is our demo that we currently have live. This is live for a very small group of people at the moment. It's just kind of like a demo application in an isolated environment showcasing what universal accounts materialize as. But this is a universal account in the kind of like current demo that we have. We actually showcase this a lot at Token 2049. We had like a coffee shop in Singapore where you can go and you could use your universal account and pay for a transaction using funds in multiple chains. That's getting in the weeds a little bit, but essentially what I have here is I have $28 that is currently spread across 3 different chains. And so I have $13 on BNB Chain, $8 on Base, and $6 on Ethereum. In reality, that means I have $14 in ETH and I have $13 in USDC, in USDT. These are spread across these 3 different chains. And so what this means is actually, as an end user, I don't care that these assets are spread across these 3 different chains. All I care about is that I have $28. This is all that matters to me, right? And so the fact that this $28 is on BNB Chain, Base, and Ethereum is an irrelevant detail to me, primarily because a universal account will automatically bridge these funds for me. And so let's do an example. Let me grab an address here real quick that I can send some funds to, and then I will do a quick transfer. Okay, so let me open up a transfer here, and let's send maybe to Optimism. Let's send 0.002 ETH. All right, that's the address field. I'm going to send 0.002 ETH, about $5 to this address here. And we are going to actually execute this transaction. Oh, I am not sharing the right slide. Thank you for noticing that. I appreciate it. Hold on one second. It shared just one window. Let's see if this works now. Thank you. Okay. Let me go back and kind of restart that a little bit. This is the universal account demo application here. I think you guys can see this now. Give me a thumbs up in the chat. I think we're good. So this is the universal account kind of demo application that we currently have that is functional within, like I said, a small group of people that we showcased at Token 2049 last week. So going back to kind of the example that I mentioned, this is an account with $28 in it. This $28 is currently spread across BNB Chain, Base, and Ethereum. I have $14 in ETH and I have $13 in USDT. As a user, as I mentioned, I actually don't care that I have these balances spread across these three different chains, BNB Chain, Base, and Ethereum. This is a largely relevant detail to me. All that matters is that in this demo, I have $28 and I can use that anywhere. So the chains and where this $28 is located, or the chains in which this ETH and USDT is located, is it doesn't matter to me, because again, it's all equally usable on any chain anywhere. And so let's kind of go through that example again. Let's go ahead and do a transfer. So I want to do a transfer of 0.002 ETH to an address on Optimism. And again, let me copy this. As I mentioned, I have this ETH. Let's actually do 0.4. As I mentioned, I have this ETH currently spread across multiple different chains. Can I pay? Let's do this. In this case, I think it's spread across 2 or 3 different chains. And so I'm going to pay for the gas fee in USDT, and I'm going to be sending around $8 in ETH to this address on Optimism. And so let's unpack this a little bit. This is a very interesting transaction here, because at the moment, I'm sending 0.003 ETH from Base. So I have $8 in ETH, like I said, spread across a few different chains. In this case, the universal account is choosing to take that ETH from Base because that's the most efficient route at the moment. Okay, so I'm taking 0.003 ETH from Base, and I'm sending it to this address on Optimism. I'm paying for gas fees with USDT on BNB Chain. So there's 3 different chains involved in this operation. We have Base, which is where the ETH is being sent from. We're sending it to an address on Optimism, and we're paying for the gas in USDT on BNB Chain. And yes, by the most efficient route, I do mean the cheapest. In this case, I believe I have ETH on both Ethereum and Base. I think I have about 50-50 in this case. I have some ETH on Ethereum, some ETH on Base. But in this case, the account is choosing to send this Ethereum from Base because it's going to be the cheapest. Between sending Ethereum from Ethereum mainnet and sending Ethereum from Base is less gas fees. And so as a result, this transaction is, I'm saving maybe $1 or $2 in gas. And so we're sending the ETH from Base to Optimism, paying for gas with USDT that's on BNB Chain. So this is all 3 different chains that we're interacting with here that we're going to basically confirm with a single signature. And so let's go ahead and confirm this transaction. I'm signing this with a social login based account. So, if this was MetaMask, then you could see the pop-up and I would click confirm. But in this case, we submitted the transaction. And I believe this should show the transaction here. So the transaction was a success. Of course, it's just kind of like an example transaction menu that we have here. But again, I just spent 0.003 ETH. I sent it to an address that I have on my MetaMask. I might even be able to showcase it here if I have Base loaded up. Let's see. I don't know if I can share my MetaMask. I'm not really sure how to, but I did receive it. I can't share it on my screen, but I'm opening my MetaMask here. I received it on my MetaMask. As you can see, I spent it on Base. I sent it to my address on Optimism, and I paid for my gas using USDT on BNB Chain. So there's actually 4 transactions involved here. We're going to get more into this later, but we did one transaction, which was kind of the settlement on Particle. Particle actually has a chain that we're going to talk about that settles these transaction sequences. One transaction on Optimism, which is the chain that we're sending to, in this case, the address. One transaction on Base and one transaction on BNB Chain. That was all done with a single signature. And the user doesn't know about any of these operations. All I know is that I had some ETH, I paid for my gas fee in USDT, and I did what I wanted to. In this case, I sent some ETH to an address on Optimism. So you can see that the same flow is going to work very well with any contract or any application. If I want to go ahead and buy an NFT or play a game or do some operation on a certain chain, the universal account's going to do the same thing. It knows that you want to spend a certain amount of tokens, knows that you want to do so on a certain chain. It knows that you want to spend a certain amount in gas with a certain token, and it's just going to do everything else for you. It'll bridge for you. In this case, as you can see, I'm bridging from Base to Optimism. It'll pay for gas from any chain for you. In this case, on BNB Chain, and it can even do this from multiple chains. So if I had this ETH spread across 3 or 4 different chains, then it would do this from 3 or 4 different chains. So the universal account, all it's doing here is handling all these transactions for you, so the user can have balances anywhere and pay for transactions anywhere. That's kind of the essence of what we're getting into here. And how this all materializes. So this same operation could be done in a real application environment, as we are going to be getting into within this hackathon. And the universal account handles everything here, from the bridging to the gas payments to everything, to basically allow the user to spend funds from any chain. Let's see, let me check the chat here. What chains are supported? At the moment, this is just a very early version that is early access. Like I said, this is just kind of like an isolated environment for testing. But once we do release the SDKs, we'll have, I believe, maybe 30 or 40 EVM chains supported approximately. For now, we have Ethereum, Base, Arbitrum, Optimism, and BNB Chain that are supported. But we're going to have a lot more supported once we do release the SDKs in the next few weeks. This is just a testing version, so we have a kind of a small, limited selection here. Do you have the inner swap of paying fee with the other chain token? So basically, it is kind of swapping it. I can actually open the transaction here. Basically, what this ends up doing is our paymaster can take funds in any token. Eventually, does get swapped back to like actual BNB to pay for the transaction, of course. But our paymaster in this case is just basically taking, in this case, USDT to, I think this ends up being a BSC USD, but it takes a tokens to then basically sponsor the transaction. And so all the paymaster is doing is it's saying, I'm going to pay for the gas of this transaction and take repayment in 0.76 USDT on BNB Chain. And so the paymaster is just paying for these transactions and then repaying itself using those funds on BNB Chain. And so it's actually a relatively simple mechanism. It doesn't require too many on-chain actions. It's a primarily off-chain interaction that we're having with the paymaster here. What is the delay in pricing data? This is just this demo. I believe it's we just do like 15-second refreshes, but of course for the actual SDK, it'll be relatively similar to other SDKs of this nature. I think it'll be pretty on par with like pretty real-time pricing data. For this, like I said, I think we do 15-second refreshes for pricing, but that's just because this is a early access demo. But the SDK should be real time in terms of actually pricing out like gas fee conversions and balance unification and token conversions and stuff like that. Is this demo accessible to us? This isn't public, but if you do want access to the demo, I can give you access. It's very early at the moment, so we're just kind of gathering some private feedback from certain testers that want to give it a try. But if you do want feedback, or if you do want to give feedback and give it a shot, then you can shoot me a DM on Twitter, and I can give you access. We're going to have a public demo next week that anybody can access. So the public demo is going to include a lot more than just this. We're going to even have like just some other ways of using this. You're going to be able to like test on different dApps and stuff like that. Then the SDKs will follow. So we'll have a fully public demo that everybody can access next week. But for now, you will need to ask me for private access, in which I'm happy to give it to you. Just shoot me a DM on Twitter, and I'll drop you an invite code as well as the link to this demo. Does it construct some kind of decision tree to find the most efficient route? I don't know exactly how it's computing this directly. This is happening on an SDK level, so it's not computing this like on chain or anything. This is just basically like our SDK figuring out and checking like how many tokens I have on which chains, and then we're doing some gas estimations and just kind of figuring out what actually results in the least amount of gas being used based on the tokens that I currently have. And so I don't know exactly the logic that we've implemented on the SDK level to compute that, but it's a relatively simple just pricing mechanism in which we estimate based on the origin chains. And so like we rank things like, I mean, of course, Base is going to be far cheaper than Ethereum. I think I currently have the $6.88 is on Ethereum. And so it could have sent those funds I just sent from Base, it could have sent that from Ethereum, but it chose not to because I would have paid maybe 50, 75% more in gas. So it chose Base because that's the cheaper route. So that's essentially, it makes decisions based on just ultimately what ends up being cheapest for the end user. But as to the specifics of how it does that on the SDK level, I'm not too sure. That's a little bit in the weeds, and kind of our engineers implement that because it's a very off-chain thing. None of that happens on-chain. But yeah, so again, if you guys want access to this demo and you want to give this a shot, just kind of mess around with this and see what this is going to look like, feel free to shoot me a DM. On the SDK level, how this is going to be implemented is that essentially there's going to be two ways to integrate this within your application. Either A, you can integrate this interface, so you can actually have users that will be able to connect with this kind of like universal account UI. And it's kind of almost like a wallet connection. So you can actually just implement this to where it's like you have a supported wallet type or a connection mechanism, which is your universal account. You connect with that, then you can use this. That method works. I would say it's like not super native. It's a little bit basic. The better way, or kind of like the more native, kind of stronger way to integrate this is actually going to be through the lower level SDK, which we'll talk about in a moment. But the lower level SDK is just simply like exposing your universal account as a smart account that you use directly through, for example, like an EIP 1193 provider. So whenever I'm constructing an Ethers object, I plug in the universal account provider object into that construction. And then I can just do transactions. I just submit typical transactions, whatever contract interaction or, whatever else it may be. And then that provider, that 1193 provider, will automatically interface with the universal account and bridge funds as needed. And then you can, whatever you want to do, you can express this information to the user. We'll expose kind of like, what funds are being pulled and from where, and at the SDK level, and then you can handle that as you want. But in general, implementation will be very, very simple, and we'll just kind of directly plug into Ethers or Web3.js, and then we'll handle all of the bridging and balance consolidation in the background. And then you can choose if you want to display this or not. So that will be the best way to integrate this. Although, of course, the other options I mentioned will just kind of be adding like a wallet menu option, which will actually use this interface as a more standard way of connecting to the application. Is the Chain Abstraction SDK helpful for beginners in blockchain? If you're building an application that uses our universal account Chain Abstraction SDK, then this will absolutely be helpful. One of the kind of biggest points of friction with like getting users into applications today is the fact that, the necessity to basically know what chains to deposit on, how do I bridge funds across chains? This is a massive barrier for beginners because it means that like they need to learn like, well, what specific chains are in the first place. They need to learn like what Polygon is and what Arbitrum is. And okay, now they need to learn about bridges and like just the fact that they need to cognitively manage where their balances are and then like how to move these balances between chains is a massive blocker for them. And so in this type of example, when you have a universal account, a user can deposit anywhere they want to. They can use assets anywhere. They don't even need to think about the chain. They just have their assets and they use them. So this removes all of the need to cognitively manage that for many users. They just use your application as is, sort of like a very similar experience to a centralized exchange, right? You just have your balance on the exchange, you use it to trade, and that's it. Very similar concept here. You just have your balance on chain, you use it for the application, and that's it. And so it is a pretty big unlock for beginners. And if you're building an application with it, I would expect that the conversion rate from like a newer user to actually a longer term retained user to your application will be far higher than it would otherwise. So that's kind of a live example. We have more features of that demo. And so, of course, if you want to give it a try, like I mentioned, please shoot me a DM. I'll give you access to it. Otherwise, we'll have a public beta next week, and then we'll have SDKs probably the week after that you can start working with to use this within your application. Like I said, this SDK, you can add this and have native support for universal accounts where every transaction that you do will go through universal account and feature that same balance consolidation property in less than 30 lines of code. It's really simple. And so everything that you just saw, like that automatic moving funds from Base to Optimism, paying for gas fees in BNB, on BNB Chain with USDT, all these things. You don't need to worry about this as a developer. You just throw in the SDK, throw in the provider, and everything else is basically handled on our side. We will compute and execute these transactions for the user, and then basically you achieve this sort of like chain agnostic user experience that we talked about earlier. So I'm going to kind of get a little bit in the weeds here of how this actually works. In the background, I won't take too long because I think I only have maybe 15, 20 minutes left. But what does this actually look like and how is this being achieved, right? So what we just saw was essentially, and you guys probably noticed as well, like that transaction was very quick. So we just did that transaction, maybe what it took 5 seconds to execute, but that was transactions that occurred across 4 different blockchains. So how do we actually bridge funds and pay for that transaction on Optimism using funds on Base, paying for gas on BNB Chain, all in only around 5 seconds? Was actually pretty simple. And so the way this works, this isn't very relevant for the actual integration, but I figured some of you guys would find it interesting. We actually use something called a solver-based bridging approach. You might be familiar with this concept if you've explored things like across or other kind of more intent-based bridging mechanisms. But very simply, what all this is doing is saying that the user signs a transaction. They have assets based on one or multiple chains. We can use the example here of, let's say I want to buy an NFT on chain 4. That NFT is $15. I have $5 spread across chain 1, chain 2, and chain 3. So all we're doing here is saying, okay, well, the user has $5 in chain 1, $5 in chain 2, and $5 in chain 3. And so we're going to convert that. Let's say that those $5 are in ETH, right? So I have $5 in ETH on chain 1, $5 in ETH on chain 2, and $5 in ETH on chain 3. The first thing that we do is we convert that to an intermediary asset. So an asset that we can kind of handle uniformly. So we, in this case, convert that to typically USDC. So we first convert all that to USDC. Then we basically have this kind of like agreement here where this liquidity provider, what it'll do is that this liquidity provider essentially, or the solver, the filler, has a balance, has a pool of USDC. So this liquidity provider on chain 4 has however much USDC, a lot of USDC. Okay, and the liquidity provider says, this agreement essentially, the liquidity provider says, I will pay for your transaction on chain 4. I'll swap to whatever asset you want to pay for the transaction on. Let's say the NFT needs to be purchased in ETH, right? I will pay for your transaction in ETH on chain 4 if you repay me that equivalent amount of ETH, or in this case, that equivalent amount of USDC on chains 1, 2, and 3. This is all that is happening here. You have a solver or a liquidity provider, whatever you want to call it, this entity that will pay for your transaction on the destination chain on chain 4 and repay itself using the assets on the chain that you want to pay with, right? So going back to the example that we just looked at with the Optimism demo, what the same thing was happening there. I wanted to pay for a transaction on Optimism using funds on Base. So all it was doing is saying, okay, well, the solver that we just used is going to pay for my transaction on Optimism and repay itself using the funds that I had on Base. And so that's all that's happening here. It's actually really simple at its core. And so this kind of graphic that I have here, we're using funds on 3 different chains. We're paying the solver, and the solver is just paying for a transaction on the destination chain, right? So we're paying the solver in USDC. The solver says, okay, thanks, I have USDC in my balance. I'm going to swap my USDC that I have already on chain 4 to whatever asset you want to use, let's say ETH, and then it's going to pay for the transaction. And so we actually don't need to wait for like typical bridging settlement or whatever. We just, it's why it's so quick, right? Because we can just use a sort of option agreement. The solver pays for the transaction, it repays itself using funds in these different chains, and that's about it. So it's a very basic idea at its core. Use an entity, it pays for my transaction, and I repay it for its work. And I repay it on the chains that it accepts, chain 1, 2, and 3. It pays for the transaction on chain 4. That's it. It's an extremely efficient, low cost, and fast way to bridge funds across chains. That's how we do it at its core. That's how basically the transaction that we just did in that demo works. That's how every transaction that universal accounts actually execute work at its core. And this is how essentially we can allow users to buy some asset or do some transaction on a chain that they have no balances on because they're, that you have the solver that's paying for that transaction, and then we're just repaying it using whatever funds that we have on the other chains. Can you share the documentation for the solver-based approach? Not able to find it under Particle Network docs. Yes, I can definitely share it. Give me 1 second here. Yeah, so this is we call this universal liquidity. So this is a technology I'll put the link in the chat. It's called, like I said, universal liquidity. It's just this solver-based approach that allows you to, use funds from any chain to pay for transactions by kind of having this option agreement with the solver where it fronts the funds for your transaction. So this is how it works in the background. It's essentially how universal accounts function, and that's how that demo that we just went through actually worked in the background. So I won't get through too deep into this, but as I kind of went through earlier, also kind of talking about the architecture, basically universal accounts are powered by 3 different mechanisms. Universal liquidity, which is what I just talked about. It's the solver-based bridging approach that allows you to basically use funds from any chain to pay for transactions on any chain, automatically bridging and kind of using that solver approach to front funds and basically repay solvers on chains that you want to pay with. We use universal gas, which is a very similar idea where we use a paymaster that will sponsor your transaction on a certain chain, then repay itself using funds on another chain. So in this case, that example that we just did, that was a paymaster paying for the transaction on Base and eventually on Optimism, and repaying itself using those funds on BNB Chain. So also very simple. And then this is a little bit more complicated, but essentially to keep this all decentralized and secure and verifiable, we have a Cosmos chain. We have an app chain essentially that will actually coordinate these transactions and settle these transactions. And so what happens here is that sequence of transactions, the bridging of 2 or 3 chains to a certain chain, or kind of what we just did, which was like moving funds from Base to Optimism and paying for fees on BNB Chain. That transaction sequence is actually settled on Particle Network's app chain and settled on our chain as a means to kind of, make sure that things are decentralized. It's a decentralized coordination layer. It's a way to actually verify that this transaction sequence is valid and introduce some degree of kind of atomic execution where we can basically verify that a transaction sequence will settle and will be valid before we actually go ahead and execute it. So again, this is information that you don't really need directly, but it basically allows us to significantly decentralize things, and it's quite an important component of this that makes that possible in the first place. And so we can actually go over to the transaction here. This is a block scout work. It's very simple, but this is not a testnet transaction. This was on mainnet, but this is the transaction that we just executed within the demo, which was, again, the transaction on Base, paying for a transaction on Optimism, using funds on BNB Chain. This is the settlement transaction on the Particle Network chain. So the Particle Network Cosmos chain, it settled this transaction on chain. This is the sequence of transactions. We don't have a lot of like expressive information here, but this is kind of the hash that represents that sequence of transactions that we just executed on those different chains. And so I'm going to go back to the presentation, but that's essentially how that works. It's quite an interesting architecture that allows everything to be very clean, decentralized, and efficient. Okay, so with that said, how can we actually use this programmatically? I have about maybe 10 minutes left, so I'm going to keep this quick. But like I said, the SDKs are not live yet. This is very important. So this is a very early explanation for that reason, but the SDKs are going to be live in the next 1 to 2 weeks. So for now, I'm going to basically showcase to you an example using our Account Abstraction SDK as kind of like a placeholder for eventually in the next 1 to 2 weeks with the Universal Account SDK, how it will be implemented. But this is a graphic that just showcases the rough idea of what you can expect in terms of implementation. The Universal Account SDK is very, very simple at its core. All it does is it just plugs directly into a signer or a provider object, and then is used within Ethers or Web3.js or VM or whatever else it may be. And so the flow goes like this. A user connects to my application using RainbowKit, Web3 modal, or we even have our own kind of connection kit SDK called Particle Connect. So the user connects to the application. That results in a signer and an EOA provider, usually provided by the connection kit, like RainbowKit or Web3 modal. So they take that provider object representing the EOA. You plug that into the Universal Account SDK. This will produce another provider object representing the universal account, because again, a universal account is a smart account. It exists on top of the EOA. It's a separate address that is signed for by an underlying EOA. And so you take that provider from the EOA, plug it into the universal account, and then you take the universal account provider and just directly add that into Ethers or Web3.js or VM, and then you just execute transactions. And so it's very, very simple. It's literally 20 lines of code approximately. You just configure the universal account, connect a user, create the provider object that you need, plug it into Ethers, and then do transactions. You don't need to do anything more. You don't need to like define where you want funds to come from or like do custom transaction objects or whatever. You just literally plug this directly into Ethers or Web3.js or whatever you want to use and do transactions as you would normally, and we'll handle the rest within the SDK. So super straightforward, very, very simple. I'm going to quickly show a programmatic example of what that looks like. Again, like this is going to be the closest I can get without actually using the SDKs as an example. Of course, I will share the documentation and the actual live SDKs as soon as they're ready, maybe next week or the week after. But this is an old demo that I have. I'm just showcasing on GitHub here with our account abstraction SDK. So again, universal accounts are just smart accounts. And so this will function essentially the same way that I just described. We have a smart account here. This is not a universal account, but this is a simple account specifically, which is just the Ethereum Foundation's smart account implementation. So what we're doing here is we are creating a new smart account object, configuring it with just some simple project keys, authenticating the SDK. We're choosing the account type. You won't need to do this with the Universal Account SDK because everything's the same account type. It's a universal account. So we're configuring that here. We have this kind of smart account object that we are creating. And then we are basically all we're doing here is just defining our Ethers object. We're constructing our Ethers provider. Our Ethers provider is a new instance of AA wrap provider, which is a kind of the construction of this 1193 provider object representing the smart account. We import that up here through the particle account abstraction SDK. We throw in the smart account configuration right here, and that's it. It's like what? This is 9 lines of code. It's super, super simple. Configure the smart account, throw it into Ethers as a provider object, and then do transactions. They were just using our Ethers object to then, whatever it may be, send a user operation. In this case, this isn't a good example because I'm not using Ethers, but if I like this, for example, this is like the transaction that I would construct, and I can use Ethers to execute that, and it'll use the universal account underneath. Very straightforward, literally 2 steps, configure the SDK, then plug it into Ethers and do transactions. That's all you need to do. The universal account SDK is going to look very, very similar to the setup here. Right, you can have a configuration that'll look exactly like this. You plug in your project keys, you do some slight config here, then you throw that into Ethers, exact same way that we do here, and then do transactions. That's it. Literally, 10 lines of code, maybe 20 lines of code. Very straightforward. That's how it works. I can showcase a similar example here. If you give me 1 second. This is an example using our Particle Connect SDK alongside our Account Abstraction SDK, but it's kind of the same core idea. Again, this is using our Account Abstraction SDK. Smart account is already configured here from a React hook, but as you can see, I am defining Ethers again using kind of this provider object representing the smart account that I'm doing a transaction. That's it. Very straightforward. Create Ethers provider using the smart account object, do a transaction like this, to the value, then send a transaction. That's it. Literally what we have here is we have 4 lines of code, technically 1 line of code to get the provider constructed. We define the transaction, another basically 1, 2, 3 lines of code, then we execute the transaction in 1 line. Very, very simple, very straightforward. And so this single line here, this construction of the Ethers provider, as long as you throw in your universal account like provider object here, then your application is now chain abstracted. That's all you need to do. Your application is now chain abstracted, chain agnostic. Every user that onboards in your application will use a smart account or will use a universal account and can deposit anywhere, use balances anywhere, and the SDK will automatically consolidate these balances and basically create that functionality that we just demoed a moment ago. And so all you need to do here is throw the provider into your Ethers object, your Web3.js object, your VM object, or whatever you're using, and then do transactions. And now you're done. Your application is now chain abstracted. It's really, really simple. And it's basically, like I said earlier, it's very low hanging fruit. It's accessible to every application type, existing applications, brand new applications. It takes 10 lines of code and you're good to go. And then you can do transactions and it'll automatically route through the universal account. And that's about it. So very simple stuff. Hopefully that was a clear explanation of generally how that will look. There's not really much more to it. It's just connect with the user, plug in the universal account provider object, do transactions, and you're done. Now your application is now chain abstracted. And so we just kind of went through that. And then again, I kind of have a slide here that goes through, again, 3 steps: connect the user, generate a new provider, initialize ethers, and then you're done. 5 lines of code, 10 lines of code, very straightforward. So the SDKs, the documentation, videos, and repositories showcasing this within the Universal Account SDK are going live soon. We're working on this all over the next few weeks. So you guys are going to be ready to get your hands on the SDKs as well as all the relevant documentation, demo repositories, and videos probably by maybe the second or third week of this hackathon. And so you can start working with the other bounty providers first, and then you can implement Universal Account second. As you saw, universal accounts are a very quick integration. It's very fast and easy. And so as soon as it's ready, I think you guys will have no problem integrating that and having that kind of be the core onboarding part in the account used within your application. So we'll share this with you guys all when they're live. You're going to be the first to know. We might even be able to share with you like an early access version of the SDKs, maybe a little bit earlier than like the public will get access to it. And so very, very straightforward. And we're really excited for you guys to get your hands on this and start using it as soon as possible. And so I think I'm right on time here, maybe even a little bit early. This is basically what universal accounts are and what we're building at Particle Network. It is an account type, a smart account that allows users to deposit anywhere, have funds that are located anywhere, and do transactions anywhere. So you can build your application, deploy it on any chain that you want to, and have users on board and use it from any blockchain that they want to. Again, this is the idea behind chain abstraction. One account, one balance on any chain. This is what we're building at Particle Network. You can learn more at particle.network and go to our documentation, developers.particle.network, to learn more there as well. Like I said, we're going to have the Universal Account SDKs ready in the next 2 to 3 weeks. I'll send that to you guys as soon as possible. And I'm very excited to see what you guys build with it. I think it's going to be like kind of a killer unlock for a lot of users and a lot of applications that should hopefully, like I said earlier, be sort of like this clicking moment for a lot of users that is going to be quite powerful. So thanks again for having me. I think was quite a productive session, and looking forward to what everybody builds with this.
Thank you, Ethan, for the lovely workshop. And thank you, everyone, as well, for being so active in the chat. And I will see you on the next workshop. Okay. Thank you, everyone.
Thanks, guys.
Bye-bye.